We move into our next keynote session, Taste of Cloud Testing, and this will be presented by Mr. Anand Vaishampayan. He is the Director of Cloud Application Migration Services for Global Delivery in IBM Global Business Services and Practice Leader for Cloud Innovation Advisory. In his 26-year career at IBM, he has played key roles in services sales, founded and led service delivery for AT&T account, and led delivery excellence, testing services, public sector, and communication sector. He's an IBM Certified Executive Project Manager. He is the chairperson of IBM's PM Certification Board, Diversity Executive Champion, and Inclusivity Role Model, President of IBM Club, Senior Location Executive for Bangalore and India South Asia Integrity Champion. And in this session, you will get an uncluttered view of how testing adds value in such a complex mesh of interdependencies in a cloud environment, and how test professionals continue to play an increasingly crucial role. So let's put our hands together and welcome Mr. Anand Vaishampayan.
Thank you for that lovely introduction. I really appreciate it. And ladies and gentlemen from the wonderful testing community, a very good morning to all of you and a warm welcome to this session, Taste of Cloud Testing. It's absolutely a great pleasure to be with you, as always. And I would like to thank my good old friend Pradeep and the entire organizing team of STC 2018 for giving me this platform and an opportunity to share with you my thoughts. I want to begin with a very provocative sort of a question. How many times have you come across a situation where if an application or a product works very well in the field, everyone says it has been very brilliantly designed, absolutely wonderfully developed. Nobody says it had been tested very creatively, right? On the contrary, if the application does not work in the field very well, everyone comes back and says, oh, testers did not do a good job. Am I right? Yep. So in my personal humble opinion, the testers and testing community need to elevate their stature to a level where there is a great degree of pull from the entire ecosystem in which the testers function. And that can come only through a very sound understanding of the technology in which testers perform their role. So on that backdrop, in this session, you would see a little bit of cloud and a little bit of testing, because I feel it doesn't make sense to exclusively talk about testing, the standard test process methodology and the boundary conditions and so on and so forth, when you're talking about cloud, without a reference to how cloud works, the cloud consumption models, the architecture, and so on and so forth. So I will try my best to not convert this into a cloud tutorial, and I'm not going to talk about the fundamentals and the basics of testing, and we will also have some fun on the way. So let's see, I have a quiz question for you to begin with. Yep. In 1956, and I know many of us and even our parents were not born in 1956, Alfred Hitchcock, a very well-known Hollywood director, released this movie, and you got to name this. Anyone? Nope. Close, but no, not Psycho. The correct answer is The Man Who Knew Too Much. And this is how I think the men and women, talented men and women who perform testing need to be, deserve to be known in the IT field. Yep. Another one. This image, I'm sure everybody would reckon with. Yep. What is the tagline there? Exactly. And in the field of cloud testing, I believe cloud testing is developers' envy and testers' pride. And that is what I'm going to make an attempt through this agenda to cover. So we would like to take a look at how large is the cloud opportunity as such, what is the size of the market. We would touch upon different consumption models for cloud. IBM has got a pretty profound methodology called Cloud Innovate. I would like to briefly describe that and how it relates to testing. testing across different consumption models, touch upon briefly the testing best practices, emerging skills which I think are relevant in the field today for testers, and conclude it with a short conclusion as such. So let's take a look at the Gartner view of how large is the public cloud revenue here. And we can take different cuts of this, but the point I'm making here is when we have a prediction of $175 billion of revenue for cloud, public cloud, testing opportunities are actually growing much faster than 17.7% at which the market is growing. Therefore, as I started saying, there is plenty of opportunity for testers to elevate themselves and make them very, very relevant in the field of cloud. Let me ask another fundamental question. What is cloud? There can be plenty of different answers depending on how you look at it, right? In my opinion, it's basically an environment where the computing resources are kept, whether owned or rented, doesn't matter, but they are available there with a fundamental assumption that these will be technically infinitely scalable, always available, and available on the stipulated service level agreements. That's a very colloquial definition you can say, all right? However, as I mentioned, this phenomenal growth of public cloud business, what exactly is driving it? This is what is driving it. And I'm sure you would realize in the cloud, there are so many different entities, so many different devices, so many applications which are constantly consuming the data which is available in cloud, processing it, performing the business processes, and providing that data, that input for future usage back into cloud. And that back and forth traffic, it's not just about data exchange, but many of the other aspects as well. To begin with, at the center, the emerging blockchain phenomenon is vastly popular these days, and all the basic concepts and the principles of blockchain I need not elaborate. The point here is that is driving the consumption of cloud. And there are many different devices, from desktops to mobile to tablet to any other form, that provides an opportunity for interface testing, for different types of UI testing, and so on and so forth. Quickly looking at it, you look at the medical devices, starting with the implanted pacemakers for heart, human heart, made by companies like Medtronic, to the wearables that we use, to the connected ECG and MRI and all those sophisticated medical devices. So it's available, the information is available, the diagnosis can be performed when these devices interact through cloud platform with so many other things, not just in country, but also across the world. Similarly, the connected cars, everybody is eager to get into the driverless cars. I'm sure we have a burgeoning entertainment industry, the gaming industry that has different consoles and the rendering engine and what have you. Similarly, a lot of analytics does take place on humongous data that is created, that is consumed through cloud, back and forth. Artificial intelligence, where we have the Watsons and Cortana of the world who are able to very well articulate exactly what is the subject matter and answer the questions and what have you. In fact, you'll be familiar with Watson, the role it is playing in the oncology and the treatment of cancer, right? That's a form of artificial intelligence. And we all love WhatsApp, we all love social media, mass media, entertainment, digital transmission of movies and what have you. The fog computing for the sensors which are embedded in the IoT devices heavily interact. So all in all put together, the consumption of cloud in whatever pattern is being driven phenomenally through these kind of devices, these kind of interactions, the applications, and so on and so forth. So exactly, what are the consumption models that I have been talking about? The answer lies here. There are three main consumption patterns or models which are prevalent in the industry today. First one is the infrastructure as a service. And here the provider basically makes the ingredients and the basic elements available which can be assembled by the network architects through the visual infrastructure management to create the backbone for the infrastructure that the enterprises continue to use. And IBM Cloud is another example. You also have DigitalOcean, you have Rackspace, you have AWS, you have Azure. There are many of them in the market today. At the next level, the infrastructure that has been created now is used by the application developers and testers to craft the applications for the enterprises. That is platform as a service. And with the help of all of these tools and services that you have provided by the Azures and AWS and Red Hat Linux, or sorry, Red Hat OpenShift platform and everything else, you create the applications. And ultimately, software as a service, where the software developers have already made that software. They are making it available for you either on a pay-per-use basis or consumption model basis, like your Make My Trip, or everybody uses Cisco WebEx, for example, and the likes. Yep. So these are the three different patterns, particularly, which are used today in order to consume cloud. Now, on the lighter side, when all of these complexities, particularly the bosses get to know, and the acronyms that they get to know, it creates sometimes a funny situation like this, where the boss is asking, do we have any actionable analytics from our big data in the cloud? And the poor guy has to respond that yes, the data shows that whenever you use this kind of a jargon, the productivity actually dips. And look at the masterpiece from the boss. Is using yet another phrase there, right? So where I'm going with this is that we don't need to really make this whole cloud business complex. Let me try and make an attempt to simplify infrastructure as a service, platform as a service, and software as a service through this particular example. We call it pizza as a service. Yeah, this was originally attributed to one of my senior architect colleagues within IBM, so feel free to quote this. So like the on-premises model, you have all the ingredients of pizza that you buy, and you make your own pizza there at home. Yep. But you can also get the pizza base, tomato sauce, toppings, and some other things, actually, and then get the rest made there at home. So it is infrastructure as a service. Whereas you can have pizza delivered, that's equivalent to a platform as a service, or a dine-in where you go out to the restaurant and just get the pizza to your configuration that you want. That's a pizza as a service that's offered. Exactly in the same fashion, if we draw an analogy with the IT infrastructure here, you have these very important elements, or the contributors to the IT ecosystem, starting all the way from applications to data to runtime, middleware, virtualization, and so on and so forth. All of this, when enterprises buy and keep it for their own usage, that's an on-premises model. Whereas in some cases, look at the infrastructure part, which is provided by somebody else, and the rest is made by the enterprises, the businesses themselves. That is infrastructure as a service. Whereas in some cases, you can have all of this made to you, available to you as a platform, wherein you build your applications with your own data. That's platform as a service. And you can buy the applications. You can rent the applications as you wish and consume them as you wish and pay for them as you wish. That is software as a service. So this particular whole modeling, or this whole particular consumption pattern, whatever I have talked about so far, you can relate with what kind of testing opportunities it is opening up. That's where I'm going with this hypothesis, okay? So to begin with, I would like to touch upon how exactly this methodology that we have created in IBM called Cloud Innovate, which is highly client-centric, looking at it from the client's mindset and a perspective, and it covers the entire end-to-end life cycle of cloud adoption. And it also has plenty of automation built into it. And ultimately, we want to ensure that this allows the enterprises to adopt and make the hybrid cloud journey a lot simpler. So to begin with, we have the fundamental pattern of service that we offer is advice on cloud. And this allows the organizations to create a roadmap for cloud adoption. They don't know exactly which cloud to go to, whether past model is good or they should buy a software, how much storage they should buy, and things like that. So we facilitate and help them create a roadmap, create a strategy there. Next one, going clockwise, is migrate to cloud. And this is where there are lots of applications which had been developed for a long time and enterprises have been using them, but they are good candidates for migrating to cloud in order to take all the benefits that cloud offers. Yeah, and that process is not just easy. You have to decide in a scientific manner based on certain value that an application is adding on technology front as well as on the business front to decide whether you want to dump that application, you want to do something else, or you want to migrate. So migration, for example, is covered under this particular offering. And a case in point, we have been delivering services for migration to a large European bank, 1,100 applications, more than 100 combinations of different operating systems and their versions, more than 70 middleware platforms, right? And we help them basically bring it down in a 3x3 model where 3 operating systems they standardize on, Red Hat Enterprise Linux, Windows, and Z operating system, or ZOS, and N-1, N, and N+ version potentially. So look at it, when we migrated those applications in a factory model in a repetitive and a consistent fashion, the kind of testing opportunities it generated. Next is the Modernize for cloud, where we have opportunities for bringing in microservices or trying to move the environment from old Algol or COBOL kind of legacy applications or legacy platform and environment to microservices or Java, for example. Yeah, and we also have the code conversion engines for RPG 400, lands on the web, sign on, for example, to move to Java and all of that. Yep, so again, it opens up more opportunities for testing. Rationalize for cloud is an opportunity to consolidate the overall portfolio that you have and get the best commercial value from the applications by eliminating some, rewriting some, modernizing some, and ultimately moving them to cloud so that enterprises really get the benefit of it. There are many occasions when we build the applications afresh on cloud. That is called cloud native development or build on cloud. And there are many examples here that I would be happy to share. For example, that elasticity point that I talked about, right? One retailer in South America had been struggling when more and more users used to reach the portal to buy products on certain days of their year, festivals and what have you. And invariably, the portal used to go down. So we helped them develop this in an elastic manner such that based on the workload, the application was able to scale up and down. Similarly, for a large airline, we built microservices such that their passengers were able to dynamically get allocated on a new flight, or they could get their refunds when there was some disruption or change in schedule and things like that, right? So this is the kind of pattern. Now let me move on to 3 different types of, I would say, models again in our overall or overarching QA strategy in which testing really drives the whole business. First and foremost, at the top, you can see the different components of the entire testing environment, including or starting with a virtual lab manager, is available in a test cloud. That particular entity also generates the load for you as required, also allows you to avail of an environment, and it stands up that environment for manual testing. It also provisions and makes available the automation tools, as well as the performance tools, the HP Performance Center, for example. It also gives you an opportunity to do data masking as and when needed. It also allows you to generate test cases when you need, and so on and so forth. So this whole test cloud that is like a self-contained entity that can be used for performing testing for the organization is also offered as a service by many enterprises to the other organizations. That is what is called test as a service. I have everything in my cloud that is required for testing, and I offer this as a service to you, right? But at the same time, the applications under test not necessarily always reside on the same cloud where this whole testing ecosystem is residing. That application can reside on a different cloud, okay, where the testing needs to be performed using all of these components that I just talked about, right? And that is where all those abilities are required to be tested when that is the scenario. So you need failover testing, you need the latency testing, you need the reliability testing, operational readiness testing, scalability, performance. I can go on and on and on. But that is how this is actually performed. Now, in a third scenario, when I mentioned that particular application is residing not on the test cloud, but on some other cloud, when it needs to scale up, it also has an ability to spawn more instances which are not on this cloud, but on some other clouds in order to really scale up, and that's possible. And when that happens, that some of these instances are spawned on another cloud, there comes a firewall in between. And I would explain on yet another slide exactly how all of these three different components can actually coexist. So I did mention earlier, right, when on this cloud, which is an application, a result of migration, modernization, rationalization, these are the different types of testing from functional to performance, latency, scalability. In my opinion, are applicable to low, medium, and high extent for each one of these classes of services that we offer. At the same time, some other organizations, they use, instead of migration, modernization terminology, they call it rehosting, refactoring, replatforming, and some cases, they replace the custom-built applications by the COTS packages, so that is called repurchasing as well. So as you would see amongst these four columns here, in modernization, all of these are applicable to a high extent, and same is the case with cloud-native development with one exception. And that is how the nature is. When you modernize the applications, all of these are extremely important and these need to be carried out. But even amongst these, there is one type of test that I personally have felt from my experience, which is extremely important, and that is equivalence test. You have an existing application, you're migrating it to cloud, and the end users would say, okay, prove that it is working at least exactly as it was working earlier. Yep, fair ask, right? Fair expectation. The problem is that functional testing can be very easily performed. These are the test cases, these are the requirements, these are the functionalities. It used to perform like this. Exactly, these are the screens, end of the matter. But what about non-functional requirements? How could you prove that it is faster, it is more available, there is no latency and things like that? And the real problem lies where there is no baseline in the earlier case where the application was running. So as a best practice, I would like to recommend that whenever you are trying to modernize the applications and test them, or rather in any of these scenarios, ensure that you create a baseline of your non-functional requirements, only then migrate, and then prove that it is working at least at that level or better. Yep. Similarly, when you have the infrastructure as a service or platform as a service or software as a service scenario for the applications, these are the different types of testing that you need to perform, and majority of these are basically functional. One is pretty straightforward, but different flavors of non-functional testing that gets performed over here. So in this case, you use the tools such as Jira and Jenkins and RFT and RIT here, whereas in case of platform as a service, tools like Chaos Monkey or Egg Cloud or Sauce Labs or Perfecto, these are typically used, and in case of software as a service as well, IBM Urban Code Deploy is of a great value. All right, so moving on, third scenario where you have the instances spawned in yet another cloud in order to take care of the scalability. So there are three different dimensions which are very, very important. The first one is whether it is an on-premises or off-premises. Second one is whether it is a private cloud or a public cloud. And the third one, if it is the same maker or same provider of the cloud, or it's a plethora of different cloud providers, so that becomes a hybrid cloud here. And when you have that kind of a scenario, typically where the applications are placed by the enterprises, depending on how sensitive is the information that you are carrying. So HRMS, for example, very sensitive data is there, personal and sensitive information is there. Healthcare systems where you have the patient data, they all reside on-prem in private cloud. And the kind of testing that you perform is typically the functional security and the business continuity. Predominantly, I'm just giving pointers. This is not something that is not flexible at all. In case of off-prem private cloud, which is a single tenancy model, typically you have security, integration, and compatibility tests, whereas in a public cloud that has got typically multiple tenants, you perform the performance testing, scalability, authentication, and very importantly, metering test. Because here, I'm supposed to pay for exactly what I'm using. How do you prove it? You have to test. And you have to write proper scripts in order to ensure that your consumption is accurately reflected. It's like getting an electricity bill for somebody else, you know. So that metering test becomes very important in this kind of a hybrid model. Now, I would like to spend a few minutes on some of the best practices. This is not an exhaustive list by any means, ladies and gentlemen. I'm sure from your own experience, you would have many of such cases, but I would like to touch upon some. In business verification test scenario, when we moved an application to cloud, one of our clients came from Sweden and had some special characters on his keyboard, and we never, ever realized that that special character can fail a test. So please be aware of it, and in a cloud scenario, ensure that you know in what environment it is going to be used. Multiple VMs simultaneously can actually help you expedite the automation or the automated test. So that needs to be provisioned there. Automated start and stop can be built in your script for automation itself, which will simulate the breakage of the network, so that it will allow or it will test the reboot automatically of the VM if that happens on the network layer. Then we have cloud-based devices. You all are familiar with the mobile testing that practically everybody carries out. So we use Perfecto as a model, and Perfecto Cloud allows us to access that from offshore, and this was a wonderful experience there. The next one is somewhat straightforward, so I'll skip. The IoT projects, testing with real devices is a challenge. And I would like to cite an example where we had developed an application for world's perhaps the best known elevator company. And we were testing the predictive breakdown of different components within the elevators. So we can't test this every time with the elevator itself. We did that, but we created simulators which became the de facto standard for us to carry on with testing the rest of the world. Then the environment management using DevOps, very often DevOps would push certain components, certain tables, and certain other entities into the production version. But unless you ensure that if you have created an index somewhere and there is no data in the table, or you have deleted a table and that has not been synced up with everything else, the referential integrity will go for a toss. And that happens very often with the cloud. Ensure that GDPR-like compliance is always met when you test cloud when you test in a public cloud scenario. And last but not the least, very important it is that in this whole cloud ecosystem, more than 60% of the components are from open source. And there are over 12.5 vulnerabilities that we ourselves have discovered. Like you have a script hijack, you have auto code injection, you have validation bypass. And typically the approach is to test the functionality of the code that you have written. But what about all this piece of code which you are inheriting or taking on board from open source? So please make sure that that gets thoroughly tested. Now, I would like to touch upon the kind of skills which, in my opinion, are very, very relevant for the testing community to keep pace with the changes. So fundamentally, how cloud environment works, the DevOps and Agile, sound understanding of blockchain and IoT, and the analytics as such, which is very important for today's world, programming and scripting aspects of it, AI and the algorithms. And the last point is very important in that row, failure points. Where exactly are the possible pitfalls where the AI can fail? Ultimately, it is a machine that has been taught by humans, so there are enough failure points potentially there. Sound understanding of the information, the interface technologies like SOAP and UI, microservices and containerization and Kubernetes and everything else you would have known and heard quite a lot. That's very important. And last but not the least, the soft skills, which are extremely important in today's world if someone wants to grow in one's career. It's not enough just to be outstanding techie, but you need to be also able to communicate and put your point across, manage the other stakeholders, negotiate, so on and so forth. So that leads me to the conclusion from everything that I have presented so far. So quickly touching upon this, the opportunity for testing in cloud is absolutely enormous, and it is for testers to go grab it. And I hope I have proven it with enough statistics and all the other points and features that I presented that this is truly the case. The world isn't static, so there are lots of changes taking place in the world of technology. So fog computing, edge computing, microservices, and everything else that you need to ensure that you're keeping pace with that. Relentless focus on automation, absolutely critical, and we cannot overemphasize that. Security, I also touched upon this. It is one of the single biggest roadblocks for the enterprises to embrace cloud. So they are going to depend, the enterprises are going to depend heavily on the robustness of the security testing. And finally, last but not the least, I firmly believe the future of testing and the testers in the cloud era is indeed absolutely bright, because like a diamond, testing is forever. With that, ladies and gentlemen, I come to the end of my session here. I really appreciate. Thank you very much. Thank you very much, and I wish you all the very best. I know I'm standing between you and the coffee break, so I don't know if we have enough time for Q&A, but I will be more than delighted to interact with you, and if you have any questions, I will make an attempt to answer those. Thank you very much. With that, Pradeep, it's back to you. Thank you.